So, when waiting for the bus, you will see the timetable says there are 20 minutes until the bus arrives. What is the uncertainty for this waiting time? So we have no information. So, from your experience, what would you guess the uncertainty is? Now, I said 2.5 minutes. I was thinking between 2 and 3 minutes. So if I see a bus that says it's 20 minutes, I don't really think it'll be 20 minutes. That's just the estimate. Estimated 20 minutes. I think it could be plus or minus 2 or 3 minutes. Does anyone have any different opinions? I'm not sure what your bus experience is like. You put 3 minutes, yeah, fine. And Matt? Nothing? Okay. Uncertainty of the time, I said maybe, well, we'll go with your answer too, because it's not like there's a right answer here. You said 3 minutes you felt was for the bus. Okay. Number 2. 2 English teachers are asked to predict an English grade. So the first teacher says, they'll get 62 or 63%. And the other teacher says, they'll get 67 or 68. So which method do we use here? It's the method that says maximum minus minimum over 2. Yeah? So, uncertainty in the grade. What's the maximum here? 68 minus 62 over 2. That's 3%. Is that okay, guys? Yeah? This one was okay for you? Okay. Now, number 3. Now, there's 2 ways to do number 3. Either is fine. You'll get slightly different answers. So you were to measure 1.72, 1.73, and 1.73. Okay? So it's, the formula. You could have just said max minus min. Oh, sorry, my mistake. I'm sorry. 1.72, 1.73, 1.73. Now, there's only one way to do it. And you have to use the formula I gave you. So first I should get the average. 1.72 plus 1.73 plus 1.73 over 3. What's that? 1.727. Yeah. So the uncertainty is divide by 3. The difference between this and this is 0.007 plus the difference between that and that is 0.003, and then the last one is also 0.003. So that's 9.7. Is that 0.016 over 3? Something like this? I'm not sure. But what's the answer here? 0.0043. That's what you said you got, Siba. And I wrote 45. Thank you. So that's 43 millimeters. I'll fix that. What is it? Yes, thank you. That's centimetre. That's millimeters. Thank you. 4.3 millimeters. But and I wrote 4.45. Sorry. Let me fix that. Where's my pen? Yeah. Okay. Good job, Siba. Did you get that, Kim? What went wrong? Did you have lunch?
Yeah.
Did you have breakfast?
No.
Maybe this is the reason. Okay. Next one. Next one was kind of a sneaky question. Which formula are you using here for number 4? Which method? Yeah, it's the uncertainty is half the smallest measurement. Now, if you read the question carefully, what's that smallest measurement this machine could make? It's 1 decimal place. So what's the smallest number it could measure? 0.1. Good. So that's 0.05 kilograms. Yeah. I was trying to trick you, confuse you a little bit. Did you get that, Matt? Yeah, Chow? Good, okay. Number 5. Number 5 I hope was okay because it was like the example I did. So this side is 1.01 meters plus or minus 0.005 meters. And this side is 1.02 plus or minus 0.005 meters. Okay, so the area is 1.01 times 1.02. What did you get for the area? It's 1.03 meters squared. Yeah? And now the uncertainty in the area is 1.03 square root 0.005 over 1.01 squared plus 0.005 over 1.02 squared. So what did you get for that? 0.0071, and here I say 72, so roughly 71 or 72. I don't think this is exactly 3, is it? Or is it? Is it exactly 1.03? Oh, it was it? 030, okay, so. I'll write it in. Yeah. Actually, no, I just wanted this answer. Here you go. That's the answer. I think, Chow, I think it was something like 302 or something. 302, yeah. Okay. Can I scroll down? Yeah? Are you cold? Are you going to freeze to death? Yeah. Do you have far to get home? Oh, you have to walk to the city centre. Will you take the bus today? You'll walk in this cold. Tough. Be strong. Okay. So, the energy is equal to 2 plus or minus 0.001 joule. Yeah. X is equal to root E, which is equal to root 2, which is 1.4141 joules. But we still need to calculate the uncertainty in X. So the trick here is to imagine, or to think of X as being e power a half. So then you can use the formula X value square root a half uncertainty in X, which is 0.001 over 2 squared. And there's no extra piece to add because it's just E by itself. It's the formula, you know, XM, YN formula. Now, I don't know, I don't think anyone got that, did they? Matt, did you get this? That looks like a no. You did get this answer?
Yeah.
Really? Okay. I believe you. 2, that's a 2. 0.001 over 4. So that's 0.0005, I think, is the answer in the end. I think. Did I write something down wrong? No, maybe? Oh, sorry, thank you, Matt. That was 1.4141 times 0.001 over 4. So what did that work out to be?
0.0035 joules.
Joules. Okay. So the answer is 1.4141 plus or minus 0.0035 joules. Okay. Number 7? Yeah? Is that the answer I got? Oh, I just said 3.5. I need to actually put in the numbers. I just wrote the uncertainty. Oh, that's what I asked. Compute the periodic time. Yeah, no, that's fine, actually. Okay, can I scroll down? So the next one, I say F is equal to 4 plus or minus 0.1 hertz. And I want the T. So T is 1 over F, which is 1 over 4, which is 0.25 seconds. Now I need to get the uncertainty in T. So the trick is to think of T as being F power minus 1. So if I use the same formula again, it's T's value times square root minus 1 uncertainty in F over F squared. So let me see, put in the numbers. That's 0.25 root 0.1 over 4 squared, I think. 0.25 times 0.1 over 4, that's 0.025 over 4. What's that? That's 0.00625. So the answer is the time equals 0.25 plus or minus 0.00625 seconds. Yeah.
So I think the last question.
Yeah.
To score.
Oh yeah. The one before this?
Yes.
Yeah.
Is 0.0.
What's 0.01?
Uh,
Oh, I wrote 0.001? Does that mean these are wrong?
the answer is correct.
I just wrote the wrong number here,
Yes.
but this is right.
Yes.
Oh, because you gave me the number on the calculator. Yeah, okay, thank you. So that's fine, alright. Okay, thank you, Matt, thank you. Do you have this one written down? There you go. You have this one? What do you have? Formula 3 can be used as well. And Formula 4 can be used as well, yeah. Yeah. You can kind of see that, with the except for the first two, they're all kind of similar. They all just have the square root and the square. Can I scroll down? Okay. So, in the last question, you have a pendulum. And you say that the length is 1 plus or minus 0.001 meter. And you say the time is 2 plus or minus 0.001 second. And I want you to calculate the g first. Alright, well, you know, t is 2 pi root L over g. So that means t squared equals 4 pi squared L over g. So that means g is equal to 4 pi squared L over t squared. So I don't know if you can sub the numbers in, please. What do you get? 4 pi, the L is 2, oh, actually the L is 2. No, sorry, the L is 1 and the t is 2. So this is 9.86, is it? Is that right? 9.86, 9.87 roughly. Meters per second squared.
Pi squared.
Yeah. Is it 9.87? Yeah. Okay. Now, the next thing we want to do is calculate the uncertainty. Now that's a little bit tricky, so please watch carefully. Can I scroll down a bit? Just a little bit? So look at this formula for g. G is equal to 4 pi squared L power 1 t power minus 2. This guy is like k, this guy is like xn, and this guy is like yn. So if you look at my rules, what happens when there's a k in front? Well, the k is still in front. So it'll still be 4 pi squared. And then what about this guy when you have x power, y power? Well, that's when you have the square root part. So it would be g's value, square root, 1 uncertainty in L over L's value, squared, plus minus 2 uncertainty in t's value over t's value, squared. Let's fill in the numbers. So this is 4 pi squared 9.87 square root 0.001 over 1 squared plus 2, or well, minus 0.002 over 2 squared. Okay, that's fine. So that's 9.87 times 9.87 times square root 0.00, oh goodness sake, help me, 2. I've lost my brain power. You have calculators, you can tell me the answer here. What'd you get, Kim?
0.55.
Perfect. It's correct. So, that means G, look, is 9.87 plus or minus 0.55 meters per second squared. No, they're right, 0.55. Now the reason I like this question, look here, I said the length is 1 meter plus or minus 1 millimeter. So would you say I was very accurate or inaccurate here? Was I very careful or not careful? I was very, very careful, wasn't I? And the time, 2 plus or minus 0.001 second. Again, I was very, very, very careful here. But even though these errors are quite small, they combine to make a pretty big error in calculating the G. So this is what I was saying earlier, Matt. When you have errors and they combine in a calculation, they always get bigger. They never get smaller. Yeah. And can I see what you did with Lorraine? I'm curious to. Have you got your page with you? You know the one you did with Lorraine, with all the calculations. You know the one I'm talking about, right? Ah, perfect. Let's see what she had you do. Good. Yeah, okay. Yeah, so the number of moles is 2.296 times 10 to the minus 3 plus or minus 5.5969 times 10 to the minus 6. The volume is 0.025 plus or minus 3 times 10 to the minus 5. This is moles and this is meters cubed, right? And then she asks you to calculate the C. The C is N over V. Well, you know how to do this. It's just this number divided by this number gives you the C. But what you didn't know how to do is how to calculate the uncertainty in the C. So I can see the formula that she uses is exactly the same as the formula I use. It's exactly the same formula, which is good. Yeah, that's good. So I hope when you look at this again, it'll make a little bit more sense, I hope. Yeah. Consider yourself lucky, because the science students don't do this, because they don't do physics. What time are we at? Oh, okay. Now remember, I need your laptop for the next class, okay? Laptop, 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 alright?